Hello everybody and welcome to a new video. Today we're going to be talking about voltage dividers. In a previous video we discussed how electronics is simply trying to control voltages and currents, and we also discussed how we can control currents with resistors. So if you had a 100 ohm resistor here, then the current of the circuit would simply equal the voltage divided by 100. We know this is the case because of Ohm's law, which says that current must equal voltage divided by resistance. But we can also use Ohm's law and resistance to control voltage as well. I want you to take, for example, this circuit. This circuit is similar to the other ones that we've seen, except now we've got 5 1 kilo ohm resistors in a row, and we've got a 5-volt battery. So if we wanted to find the current going through this circuit, we could use Ohm's law to say that I must equal to V divided by RT, or the total resistance, where RT is equal to 1K plus 1K plus 1K, so equal to 5 kilo ohms. Right, we're just adding these up because they're in series. I is equal to 5 volts divided by 5 kilo ohms, which is going to equal to 0.001 amps or 1 milliamp. Now, here's the clever part. We know that voltage is just a measure of potential energy, and we know that it has to start at 5 volts or 5 joules per coulomb, and it has to lose all of its potential energy before it reaches this end and becomes 0 volts at the negative end. And we know that this potential energy will most likely be lost as heat through these resistors. But exactly how much potential energy are we going to lose as it goes through each resistor? Well, what we can do is we can take Ohm's law and we can rearrange it so that voltage is at the front. And we find that the resistance multiplied by the current is equal to the voltage, or rather the difference in potential energy through the resistor. So using this value of 1 milliamp, which we found before, and we know has to go through the entire circuit because of Kirchhoff's current law, the current going in has to be equal to the current going out, has to be equal to the current going out here, in here and out here. It has to be equal across the whole circuit because it's a straight line. If we take the value of this resistor, 1 kilo ohm, and we multiply it by 1 milliamp, that's just simply going to equal to 1 volt. That means that across this resistor, the potential energy goes from 5 volts to 4 volts because there's a difference of 1 volt. What I hope you can gain from this video is an intuition of how voltage across resistors work. Because you have this potential energy that gets lost through these resistors. If you have 5 equal resistors and you know that the voltage must drop from 5 volts to 0 volts through those resistors, assuming that no voltage is lost through this almost perfect conductor here, right? And we know that the potential difference lost is proportional to the resistance, then it only makes sense that an equal amount of energy is lost across each resistor here. It has to be. It doesn't matter if these were 1 kilo ohm. This could be 5 kilo ohm and 5 kilo ohm all the way down. As long as you have 5 equal parts, then the voltage loss across all of them must be equal. Anyways, back to our example. If we know that across each one of these resistors, we're going to lose 1 volt of potential energy, and it's going to go from 5 volts to 4 volts to 3 volts. What we can do is we can split the circuit off here and split the circuit off here. And for 0 load, we know that this must be 3 volts and that this must be 0 volts. And you can see now why it's called a voltage divider. We can't actually gain any voltage with this circuit, but we can divide the voltage so that we can have a proportional amount of the original voltage. And if you remember our video about resistors in series, we can simply combine these to be bigger resistors. So this can be a 2 kilo ohm resistor, and this here can be a 3 kilo ohm resistor. And that there is our voltage divider circuit, which lets us control voltages in electronic circuits.